Okay, back to the wonderful world of modeling. We're still going to be doing some modeling of linear equations now. But how about systems? Same thing. Two scenarios, each represented by an equation, two equivalent expressions. You just have to write a verbal model for each equation. Substitute and then solve. Good news, we know how to do all of this algebraically. So let's jump right in. We have a friend went to the store, bought 2 boxes of pencils and 8 notebooks for school for himself. Cost $11. He went back to the store, bought supplies for his younger brother, spent $11.25 on 3 boxes of pencils and 5 notebooks. How much does each item cost? Okay, well, one model is his supplies, or one equation is his supplies. The other is his brother's supplies. The 2 trips that he went to the bathroom, that he went to the store to purchase his supplies. So it's the quantity of how many pencils that are purchased times the total amount of the cost of the pencils plus the quantity of notebooks times the cost of the notebook. That's how much it's going to cost him. That's exactly how you add up items when you purchase something from the store. So we make the substitutions from what's given in the problem. Now, we're finding the cost. We're not given the cost. We're given the quantities of each one. So in this case, the quantity of the boxes of pencils that were purchased, well, this first equation is representing, or this first equation here is representing his supplies. So he goes and he buys 2. Let's call the cost of the box of the pencils X. He buys 8 notebooks. Let's call the cost of the notebooks Y. His total cost was 11. Same thing in here. Let's fill in the total cost of or how many boxes of pencils and notebooks that he bought on his brother's trip. Well, he bought 3 boxes of pencils, same X, same variable, right? It still represents the cost of the box of pencils on that day when he went. And he bought 5 notebooks. So that's multiplied by Y, total cost of notebooks. And on that second trip for his brother, he spent $11.25. So decimal there. Woo! All right, so let's take a look at this solution. I'm saving some time here by not writing this out, but essentially this up here is our system, right? So to solve this system, we can't just multiply both equations. We need to multiply one equation. We actually need to multiply both equations. So let's take a look. This equation here, this top equation I'm highlighting in yellow, that's getting multiplied by 3, right? This bottom equation that I'm going to highlight in green, that is getting multiplied here, down here by -2, right? Then these that I'm going to highlight here in blue, these equations are my outcomes, right? So I did the my multiplied the yellow equation by 3, and I got my blue outcome down here. I multiplied my green equation by -2, and I got this blue outcome down here. So this then is my system. Solve this algebraically using elimination, add them up, get 14y is equal to 1050, divide both sides by 14, get y is equal to 0.75. That's my cost of my notebooks. Plug that back in to get the cost of the pencils. So in context here, the solution coordinate is 250, 0.75, or in context, box of pencils costs 250, a notebook costs 70.